Welcome to this tutorial on Generative AI Model Architecture. In this video, we'll explore how different generative models are designed, how they learn from data, and how they produce new content such as text, images, audio, and code. What is Generative AI Model? Most people are already familiar with popular generative AI applications such as ChatGPT, which demonstrate how AI can interact naturally with users and generate human-like responses in real time. When a user enters a prompt or question, a powerful background engine processes the input, analyzes intent and context, and then generates a meaningful output that is displayed on the screen. This background processing engine is known as a model, and in the case of ChatGPT, the model is responsible for understanding language patterns and producing accurate contextual responses. Beyond ChatGPT, there are many other generative AI models available, each designed with different architectures, training methods, and strengths to handle diverse generation tasks. Every generative AI model has specialized capabilities, allowing it to process specific data types and generate outputs such as text, images, audio, video, or programming code. For example, DALL-E is a powerful generative AI model built specifically to create high-quality images, edit visuals, and perform visual reasoning using natural language prompts. In general, a generative AI model is an artificial intelligence system created to generate new content by learning patterns, structure, and relationships from very large datasets. These models are trained on millions or even billions of sentences or samples, enabling them to produce new content that sounds natural and original. Because they learn underlying data distributions, generative AI models can create outputs that have never existed before while still maintaining realism and coherence. To better understand how these systems work, it is important to explore the different types of generative AI model architectures used to build such intelligent capabilities. Let's explore the major types of generative AI architectures, examine real-world model examples for each, and understand how these models are applied across different use cases and industries. Generative Adversarial Networks, GANs. This architecture is powerful deep learning models that use two competing neural networks, a generator and a discriminator, to create highly realistic synthetic data like images, text, or music that mimics a training dataset. GANs are widely used for image synthesis, image enhancement, deepfakes, and creative visual generation tasks where realism is critical. Example model name for the GANs architecture. GAN-based models are widely used for realistic image and media generation. They focus on visual fidelity and sharp output quality. Use cases for GANs architecture model. GANs are ideal where realism and visual quality are critical. They excel in creative and simulation-based tasks. Variational Autoencoders architecture. This architecture is powerful deep learning models that learn the underlying structure of data to generate new, realistic samples, combining autoencoders with probabilistic methods for smooth, continuous latent spaces. It's commonly used for image generation, anomaly detection, and data augmentation, where interpretability and stability are important. Example model name for the Variational Autoencoders architecture. VAE models emphasize structured data generation and representation learning. They are commonly used in research and data synthesis. Use cases for the Variational Autoencoders architecture. VAEs are suited for controlled and interpretable generation. They are popular in data modeling tasks. Autoregressive architecture. This architecture is statistical and machine learning techniques that predict future values in a time series by using a linear combination of its own past values, essentially regressing a variable against its own history. These architectures are especially effective for text, speech, and code generation, where order and dependency between elements are essential. Example model name for the autoregressive architecture. Autoregressive models dominate text and code generation tasks. They focus on stepwise prediction accuracy. Use cases for the autoregressive architecture. They excel where order and sequence matter most. Natural language tasks are their strongest domain. Diffusion architecture. This architecture is powerful deep learning tools for creating realistic data like images, audio, video by learning to reverse a gradual process of adding noise to data, essentially transforming static of random noise back into coherent, high-quality content, famously powering text-to-image generators like Stable Diffusion, Midjourney, and DALL-E 2. Example model for the diffusion architecture. Diffusion models are known for producing high-quality images. They are widely used in modern creative AI tools. Use cases for the diffusion architecture. Diffusion models excel in high-resolution content creation. They provide controlled and stable generation. Transformer architecture. This architecture scale is extremely well with large datasets and computational resources, making them the backbone of modern large language models. They are widely used for text generation, translation, summarization, multimodal AI, and intelligent assistance. Transformer-based models use self-attention mechanisms to process input data by understanding relationships between all elements simultaneously rather than sequentially. This architecture allows efficient parallel processing and captures long-range dependencies effectively. Example model name for the transformer architecture. Transformer models power most large language and multimodal systems. They are flexible and highly scalable. Use cases for the transformer architecture. Transformers dominate language, reasoning, and multimodal tasks. They form the backbone of modern AI platforms. Thanks for staying with us. If this session added value, please like, comment, and share it with your network. Thank you for watching and see you in the next lesson.